Today's lesson will be over limiting reactant. Please get out your notes, something to write with, a calculator, and a periodic table. In a chemical reaction, one of the reactants will usually run out before the other. At this point, the reaction will stop because one of the reactants is used up. The reactant that is used up first is called the limiting reactant. It controls how much of the other reactant you will need, and it also controls the amount of product you can make. The other reactant is called the excess, because there will be some left over. Here is an example with grilled cheese sandwiches. You're given 10 pieces of cheese and 50 pieces of bread, and the equation for making grilled cheese sandwiches is below. You're going to need 1 piece of cheese plus 2 pieces of bread to make 1 cheese sandwich. How many complete grilled cheese sandwiches can you make? Well, let's look at each ingredient. From 10 pieces of cheese, where 1 cheese can make 1 sandwich, you can make a maximum of 10 sandwiches. With 50 pieces of bread, where 2 bread can give you 1 sandwich, you can make a total of 25 sandwiches. Well, if you think about it, by the time that you have finished making the 10th sandwich, you have ran out of cheese. Therefore, you can only make 10 complete grilled cheese sandwiches that have both cheese and bread. What is the limiting reactant in this case? In other words, which ingredient ran out first? Well, that would be the cheese. What is the excess, or the one that is left over? The bread. The next question asks, how many pieces of the excess reactant will be used? You will start with the limiting reactant and convert it to the excess reactant. So you will use up all 10 pieces of cheese, where 1 piece of cheese and 2 pieces of bread can make a grilled cheese sandwich. So you will use 20 pieces of bread in total. How many pieces of the excess reactant will be left over? Well, you started with a given 50 pieces of bread. You will use up 20, therefore, you have 30 pieces of bread left over. So the answer is 30. Looking at this balanced equation, assume that copper 2 chloride is the limiting reactant. Which substances will be present in the reaction container once the reaction has stopped completely? Well, you can think about it logically. If copper 2 chloride is the limiting reactant, it means copper 2 chloride will be completely used up. What's left over will be the aluminum, which is the excess reactant, and both of the products, copper and aluminum chloride, which means that all but the limiting reactants are present. Finally, classify the above reaction as one of the 5 basic types of chemical reactions. This equation represents a single replacement. In basic stoichiometry problems, you are provided with only one given quantity. In limiting reactant problems, you are provided with amounts of both reactants. Before you can solve the stoichiometry problem, you have to find out which of the 2 reactants is your limiting reactant. The limiting reactant is used as the given quantity in all calculations because it controls the amount of the other reactant used and products made. It is possible to have 2 reactants run out at the same time, and if this happens, the amounts of reactants are called stoichiometric amounts. In this special case, you can use either reactant for the limiting reactant. It does not matter. How to find the limiting reactant? First, you will start with the given amount of one of the reactants. We'll call this reactant A, and solve for the amount of one of the products. We'll call this product C. Next, start with the given amount of the other reactant, reactant B, and solve for the same product. This is very important. You must solve for the same product both times so that you can compare them. Finally, the reactant that produces the least amount of product is your limiting reactant. You must then use the limiting reactant to work any additional stoichiometry problems. Let's look at a practice problem. Find the limiting reactant if 0.5 moles of each reactants are available. Once the equation is balanced, you will write down the given of each reactant. In this case, both of them are 0.5 moles. So the goal is to find out how much product can be made. Therefore, starting with 0.5 moles of calcium, I will get rid of mole calcium and get to mole of calcium oxide on top. The numbers come from the coefficients in the balanced equation. This is step 2, mole-to-mole ratio. The calculation will give me 0.5 moles of the product. Next, I must do the same to the other reactant, which is 0.5 moles of oxygen, and I must get to the same product on top, which is calcium oxide. This gives me 1.0 mole of calcium oxide. Based on these results, calcium gives me the smaller amount of product. So calcium is the limiting reactant. Let's look at the next problem. Find the limiting reactant if 0.25 moles of aluminum and 0.35 moles of copper 2 chloride are available. First, I have this equation that is already balanced. Next, I have written down the given amount of each reactant. Since this reaction will produce two products, copper and aluminum chloride, you must select one product to get to in your calculations. I will pick copper to work with, but it is completely okay if you decide to go with aluminum chloride. Starting with 0.25 moles of aluminum, I must get rid of moles of aluminum and get to moles of copper on top, which is the product that I have chosen. The numbers come from the coefficients in the balanced equation. This gives me 0.38 moles of copper produced. With 0.35 moles of copper 2 chloride, I will need to get rid of mole copper 2 chloride by placing it on the bottom and get to the same product on top, which is moles of copper. This gives me 0.35 moles of copper produced. Based on these results, the given amount of copper 2 chloride will give me the smaller amount of product, only 0.35 moles. Therefore, the limiting reactant is copper 2 chloride. Problem 17 is slightly harder. Part A. Find the limiting reactant if 6.20 grams of aluminum and 48.5 grams of copper 2 chloride are available. We are dealing with the exact same balanced equation as the previous problem. However, our given amounts are now in grams. Here, I have written down the given amounts of both of my reactants. Since my given is in grams, I must do step 1, which is convert to moles if needed. So I must get rid of grams aluminum by placing it on the bottom and get to moles of aluminum on top. The numbers come from the conversion factor. 1 mole is equal to X grams. 26.982 is the molar mass of aluminum. Now I will get this to moles of product. And remember, if you have two products in the equation, you have the freedom to pick one of them. I will stick with my last decision on copper. So in mole-to-mole ratio, I will get rid of mole aluminum and I will go to mole of copper on top. The numbers come from the coefficients, which becomes 0.345 moles of copper produced from aluminum. Next, I will do the same for the given amount of copper 2 chloride, which is in grams. I need to get rid of grams copper 2 chloride by placing it on the bottom and get to moles of copper 2 chloride on top, just 134.452, which is the molar mass of copper 2 chloride. Step 1 is now complete. In step 2, mole-to-mole ratio, I must get rid of mole of copper 2 chloride and I will go to moles of copper, which is my chosen product in the beginning. Remember, both reactants must go to the same product. This is equal to 0.361 moles of copper produced. Between these two amounts, 0.345 is smaller, which means aluminum yields the least amount of product, which makes aluminum the limiting reactant. Part B of question 17 asks, how many grams of copper will be produced? The hint is to start with the limiting reactant, which is now determined to be aluminum. So starting with the given amount from part A, I have 6.20 grams of aluminum, which I must convert to moles of aluminum. I will get rid of grams aluminum and place mole of aluminum on top. In step 2, mole to mole ratio, I will get rid of moles of aluminum by placing it on the bottom. And on top, I will answer the question by placing moles of copper. The question asks for grams of copper, so I'm not done. I must go to step 3. Moles of copper must go on the bottom in order to cancel out, and grams of copper needs to be placed on top to answer the question. 63.546, which is the molar mass of copper, goes in front of grams. The final answer is 21.9 grams copper, which has 3 sig figs just like the given. This is how much copper can be produced from the limiting reactant aluminum. Part C asks, how many grams of the excess reactant will be used? Again, we start with 6.20 grams of aluminum, which is the limiting reactant. Repeat step 1 in order to get rid of grams of aluminum and get to moles of aluminum. In step 2, moles to moles ratio, we get rid of moles aluminum. But this time, we are going to the excess reactant, which means we're going to moles of copper 2 chloride. We use the numbers from their coefficients, and now step 2 is done. The question asks how many grams of the excess reactant will be used. We need to get rid of moles copper 2 chloride and go to grams of copper 2 chloride on top, where 134.452 is the molar mass of copper 2 chloride. The answer is 46.3 grams of copper 2 chloride was used. Finally, how many grams of the excess reactant is left over? We were given 48.5 grams of copper 2 chloride in part A. In part C, we calculated that 46.3 grams of copper 2 chloride were used. Take the given, subtract by the used, and we have 2.2 grams of copper 2 chloride left over. Now pause the video and try problem 18 on your own. So you should start the question by writing down the given for both of your reactants, which in this case are in grams. You will need to do step 1 for both, converting from grams of given into moles of given. Please keep in mind that hydrogen and oxygen are diatomic. 2.016 is the molar mass of H2, and 31.998 is the molar mass of O2. In moles to moles ratio, you're getting rid of the moles of both given. And for both, you're going to the same product, which in this case is H2O. So moles of H2O goes on top. For this problem, you didn't have to pick a product because there is only one product. The numbers that goes in front of moles to moles comes from the coefficients. Comparing between the results, 50.0 grams of oxygen produces the least amount of water. Therefore, O2 is the limiting reactant. Using the limiting reactant oxygen, you can start part B. You must get rid of grams and go to mole of oxygen, completing step 1. Step 2, moles to moles ratio. You will get rid of moles oxygen by placing on the bottom and get to moles of water in order to answer the question. The question asks for mass of water. Grams is used to measure mass. Therefore, grams of water goes on top. 18.015 is the molar mass of water. The final answer is 56.3 grams of water can be produced from the limiting reactant. Part C. Start with the given of the limiting reactant once again. And since it is in grams, we need to get rid of it. Remember, 31.998 is the molar mass of O2 because oxygen is diatomic. Step 2, which you must always do. You're going to get rid of moles of oxygen and the question asks for excess reactant, which in this case is H2. So you have moles of hydrogen on top. You must do step 3 because the question asks for grams of H2. So getting rid of moles of hydrogen by placing it on the bottom, put grams of hydrogen on top, where 2.016 is the molar mass of H2. The final answer is 6.30 grams of H2 used. Finally, you must use the given amount for hydrogen, which is 50 grams, and subtract the amount used, which is 6.30 grams, and that leaves 43.7 grams of hydrogen left over. And that's the end of today's lesson on limiting reactant. Please do the corresponding pages in the practice packet.